we're talking scatter plots, we're talking correlation here. If you plot some data on a scatter plot, which is just a bunch of little points every now and again, and all the points seem to follow a general up and to the right look to them. That's what's said is a positive correlation. It's like a positive slope. If they kind of all have a negative slope amongst them, that is a negative correlation. And if they're all over the place, that is no correlation, right? So you can graph these and figure out lines of best fit with technology, but we're going to try today without technology, minus a calculator maybe, but not one that does all the work for us. And it will get us close to what a calculator would be able to do. Let me scooch over and make myself smaller here. So looking at the statistics here, we're talking about points scored in 10 games based on the number of minutes that you play. And typically, the more minutes you play, the more points you're going to score, right? Unless you're like me and you're just coming off the bench and not scoring any points anyway. I mean, I can play for 40 minutes and score 2 points. But in general, the more minutes you play, the more points you score. So first thing we're going to have to do is we're going to have to get all these onto the graph. Now I see that our highest number of minutes played is 39. I know this graph is 19 across, and 19 times 2 is 38. So if I go by every 2, I'll be fine. I'll have 1 point that's just slightly off. But I'm going to mark off like every 10. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. 2, 4, 6, 8, 30. So we're going to label it. This is my minutes play. I'll just put minutes. And then the points will be our y. And again, it's 19 of them. My points go up to 31, so I'll just go by 2s again there. So 2, 4, 6, 8, 10. 2, 4, 6, 8, 10, 20, 2, 4, 6, 8, 30. There we go. So just putting points on the graph. We have 28 minutes is 16 points. There's 28, 16 is right there. We have 35 minutes and 13, 2, 4, 5, 2, 4, 6, 8, 10, 12, 13. It's not going to be perfect when I'm doing it by hand. Come on now. 8 minutes, scored 2 points. That sounds a lot like me. 2 points was a good game for me. 20 minutes was 12 points. 20, 2, 4, 6, 8, 10, 12. We have 39. That's a little bit off. They scored 31 points. So let's see. 30's up here. Be about there. Pretty close to our graph. 23 and 10. 2, 3, 2, 4, 6, 8, 10. 19 and 9. 2, 4, 6, 8, 9. It's about there. 27, 15. 2, 4, 6, 7. 2, 4, 6, 8, 10, 12, 14. That was 15, right? All right, and then 15, 4, 12, 14. 15, 4 is right there. And the last one, 30, 19. Is that 20? I'm having a hard time. All right, so in general, this has a positive, if it'll let me, there we go, positive correlation because you'll see all of them kind of go up and to the right. Now, if we were to come up with an equation here, we're going to draw a line of best fit. Now, a line of best fit is one straight line that ideally you're trying to hit as many points as you can. And if you can only hit 2 points no matter what, then try to hit 2 points that are in the middle of this blast. So let's say I drew a line like this one. This might be a pretty good line. I mean, that kind of hits. I mean, that's not a straight line because I can't draw a straight line up here. But let's pretend like that's a straight line. Now this coordinate here, this is the 15, 4, right? Is that a set? 15, 4. And then this coordinate here is at 28, 16. Is that a coordinate as well? All right. So we can use these coordinates and our knowledge of graphing and slope-intercept and point-slope form. First thing we're going to do is figure out the slope between these 2 points. So remember, slope is when you subtract your y's on top. It would be 16 minus 4, and then our x's on the denominator, which would be 28 minus 15. So 16 minus 4 is 12. 28 minus 15 is 13. So that could be our slope. That's not bad. And then what we can do is we could just take either one of these coordinates, use them in our point-slope formula, move some stuff around, and then we're done. So let's take 28, 16. So 16 is our y coordinate, so it'd be y minus 16 equals, we have our slope, 12/13, and then x minus, what was our x coordinate, 28? Now a lot of times with these, you will see them written as decimals, and that's cool, like even the slope. We can work it with fractions. It's just kind of going to be more of a pain in the butt than it's worth. So here's what we're going to do. We're going to distribute that 12/13, and we're going to turn it into a decimal. So let's see, y minus 16, come on. I don't know what's going on. There we go. Equals, let's see what 12/13 is as a decimal. 0.923 would be our estimate. 0.923x minus, and we're going to do that 12/13 times the 28. Times 28 equals 25.846. It's a little jammed up. And then the only other thing we need to do is get y by itself. So we will just add 16 to both sides if that ever decides to show up. We will get y equals 0.923x minus 16. I did that wrong. 16 minus 25.846 minus 9.846. So this gives you kind of a general correlation formula. Now, if the number in front of the x is close to 1, that's pretty nice. It shows a pretty strong correlation. It's also our slope. So let's try another one. What do you say? Anthropologists can use the femur or thigh bone to estimate the height of a human being. The table shows us the results of a randomly selected sample. Make a scatter plot of the data with femur length as the independent variable. Find the line of best fit. So femur length, independent is always your x, right? And usually it's time, but in this case, it will be femur length. Mr. Mackey, how you doing? Good. So you don't have a class, not yet.
Nope.